Friends, today's subject of discussion is Sandmeyer's reaction. This is a reaction which is given by Sandmeyer and hence it is named after him as Sandmeyer reaction. Here he is the chemist named Trogut Sandmeyer who gave this reaction. Before going to the reaction, let us look into the Sandmeyer. He is a Swiss chemist who gave this reaction in the year 1884. He not only gave this reaction, he also worked on the synthesis of isetine and its derivatives. Hence, several reactions have been named after him. To name the few, Sandmeyer isonitrosoacetanilide isetine synthesis given in 1919, Sandmeyer diphenyl urea isetine synthesis. He began his career in the year 1888 with Johann Rudolf Gigi and Marion, who are the owners of the chemical company J.R. Gigi and C, which is named after as Seba Gigi Research Center later, and now it has named as Novartis Laboratories. He also involved in the synthesis of several dyes. He gave a new synthetic route for the synthesis of indigo dye. Now, let us look into Sandmeyer's reaction. In this reaction, we synthesize aryl halides by using aryl diazonium salts. In other words, it's a conversion of aryl diazonium salt to aryl halides. This is an example of a radical nucleophilic aromatic substitution. You have seen about nucleophilic substitution reaction and we have seen it about free radical substitution reaction. Here this is radical nucleophilic aromatic substitution reaction. In case of nucleophilic substitution reaction, nucleophile is involved. In free radical substitution reaction, the radical is involved. A free radical is involved. Here, there is an involvement of both free radical and a nucleophile. Hence, it is named as radical nucleophilic aromatic substitution reaction. In this reaction, the diazonium group in aryl diazonium salts is replaced by halogens like chlorine or bromine. The uniqueness of the reaction lies in that the halogen is introduced at the desired position of the aromatic ring. If I take toluene and halogenate it by halogenation, what will I get? As the toluene has methyl group, which is an electron donating group, it is ring activating. Hence, it will be ortho-para directing. Either I'll get parachloro or orthochlorotoluene. If I want metachlorotoluene, I won't be able to get it by this halogenation process. Thus, the alternative to get meta halo derivative, I will go for Sandmeyer's reaction. What is this reaction? I'll take an arylamine, treat it with sodium nitrite and hydrogen halide like HCl. I'll get corresponding benzene diazonium halide salt. This aryl diazonium salt which is formed, I'll treat with cuprous halide. I'll get corresponding aryl halide. This involves two-step reactions. The first step is treating an aryl amine with sodium nitrite and HCl at 0 to 5 degrees centigrade to give corresponding aryl diazonium salt is a process of diazotization. Is a diazotization reaction. Shall you look into the mechanism of this? Sodium nitrite Na plus NO2 minus react with HCl in aqueous form H plus Cl minus. As we know that these are positive and negative ions, and positive and negative ions in sodium nitrite Na plus NO2 minus, they react together. H plus combines with NO2 minus to give HNO2, that is nitrous acid. Sodium plus combines with chloride ions to give rise to sodium chloride. The nitrous acid formed is highly unstable. That's why it is always generated in C2 and utilized immediately. The nitrous acid formed reacts with aryl amine. How this reaction occurs? As the nitrogen here is attached to the electronegative group, that is oxygen, it renders this nitrogen slightly positive. The nitrogen in the aryl amine is in sp3 hybrid form, and hence it has lone pair of electrons. Nitrogen in aryl amine is electron rich. Nitrogen in nitrous acid is electron deficient. As this electron deficient is electron rich and unlike poles attract each other, the lone pair of electrons on the nitrogen is donated to the electron deficient nitrogen on the nitrous acid. And it has to maintain its tetravalency. That's why OH gets kicked off. OH minus and H plus, they combine together to lose as water molecule, and a bond is formed between the nitrogen of the aryl amine and the nitrogen of the nitrous acid. Then the nitrogen hydrogen bond breaks. The bond is formed between the adjacent nitrogen. This occurs because the nitrogen here is positive due to the electronegative oxygen. And it has to maintain its trivalency over here. That's why pi electrons shift onto oxygen. This become O minus. The O minus combines with this H plus and loses as water molecule as and give as OH. Then again there are lone pair of electrons which forms bond with the adjacent nitrogen, and OH minus gets kicked off. OH minus combines with H plus, to which HCl is added, and it loses as water molecule, and N triple bond N, which is formed, combines with chloride and gives benzene diazonium hydrochloride. I got aryl diazonium salts. This aryl diazonium salts reacts with cuprous halide to give rise to corresponding aryl halide. Here there is N plus that I represent here as N2 plus. Reacts with Cu plus, it loses nitrogen. Once the electron is taken away from this, I get a aryl free radical and Cu2 plus ion. The aryl free radical reacts with the halide Cu plus X minus what we have. The one electron from X is taken and other electron from this is shared with this benzene aryl radical, and the bond is formed and this one excess electron is removed. that again combines with Cu2 plus to give back Cu plus. And hence, here the X minus is the nucleophile, aryl radical is the free radical, the radical and the nucleophile. Both are involved, and this is aryl group that is named as radical nucleophilic aryl substitution reaction. This has lot much of application. If I treat with cuprous chloride, I'll get corresponding chlorobenzene. If I treat with cuprous bromide, I'll get corresponding bromo derivative. If I treat with cuprous cyanide, I'll get corresponding aryl nitriles. This has also been utilized to convert aryl amines to phenols. Aryl amines upon treatment with sodium nitrate and H2SO4, I'll get aryl diazonium salt. This aryl diazonium salt, when I hydrolyze in the presence of cuprous oxide, I'll get corresponding phenolic compound. These are the utilities of Sandmeyer's reaction. In next, we go with other reaction. Till then, have a nice day. Thank you.